Thanks for joining me again today. So today I wanted to talk about some of the more important classes that you'll come across in electrical engineering towards the beginning of your educational career. One thing that I found really weird is that sometimes professors just show up to the class and they just start scribbling or just start going through the material, or they'll talk about the course syllabus and how the grades are distributed. I wish they put a little more time and effort into explaining why that course is important. It seems like a no-brainer, right? Okay, well, you're an engineering student, of course you're going to take engineering classes, but just take the little bit of time to explain, hey, listen, whatever you're about to learn here, here's where you're going to see this again. So don't just take the exam and just pass, or just get the lowest grade and just say, oh well, check mark, I'm done, I can get enough credits to graduate. Of course, all that is important, right? I mean, we go to college, you definitely want to get grades enough to graduate, but you definitely want to retain knowledge, right? That's the whole point. When it comes to electrical engineering, in the very first year, circuit analysis is the first electrical engineering related class. A full-blown course on circuit analysis is the first class that you'll take. A very critical class, okay? Something that you might even know a little bit about because it's covered in physics. So physics, whether it's high school physics or maybe you took physics in the first semester, because usually circuits is done in the second semester, circuits 1. You can do basic, Ohm's law, KVL, KCL. These relationships are simple enough that you can teach them in a physics class. But you'd be surprised that as circuits get more and more complicated, I have seen people later on towards the end of their engineering education still make mistakes. Okay, and that's because the rules of KVL and KCL have not been fully understood. Okay, so when you do circuit analysis, of course you want to know the basic principles. You want to understand Ohm's law, you want to understand KVL, KCL, nodal analysis, and there's reducing the circuit to its Thevenin equivalent, active and passive components. But understanding the relationship between them. It's not enough to know that, a capacitor. Let's see, some people will just say, well, the only way to understand it is that AC goes right through, but DC doesn't. Those are good places to start. Developing an intuition is definitely a good step towards educating yourself on the broader concepts. But what you really want to do is understand the mathematical relationships as well. You want to understand, what would happen if the capacitor size was increased and decreased. What would happen if you put it in parallel, in series? What the relationship would be without necessarily solving the whole equation. Same thing with inductors, same thing with diodes, batteries, dependent sources, independent sources. You want to look at all of these things from a perspective of knowing what they will do in a real world scenario. So definitely before you even get to that, you have to know how to solve them as well. So work on your circuits. You're going to see that class and the basics using circuit analysis show up throughout your electrical engineering engineering degree, and even in your jobs. You might not even do like power systems. Power systems has a lot to do with circuit analysis, right? Three-phase systems and whatnot. But understand this: electricity powers everything. So whether you're working on communication systems, RF systems, could be electronics devices. The concept of circuit analysis will not go away. That's not going away. And it's so weird that you have to be good at this class and the basics that show up in the beginning of your, basically in your freshman year, and yet it will impact your entire time that you're there for your degree. So you could be a senior and yet yes, there are ways to make it all the way to senior without really knowing how to do circuit analysis. But you don't want to be one of those students, right? It's going to impact you very negatively when you show up to an interview and somebody gives you a simple circuit to solve. It's going to impact you negatively on a personal level when you're given a project and you just keep stumbling to do like the basic things, which is even understanding what you're looking at. And yeah, that can happen. So my suggestion is, without going into other details, if you're an electrical engineering student, if you're in your freshman year, sophomore, even if you're in your last year, even if you have graduated, all right, and you feel that you didn't get a good grasp for circuit analysis, There's a lot of resources available. There are great courses on YouTube for free. Check them out. Tie it in with physics so you can understand the electromagnetism, you can understand the actual physics of electricity, the actual physics of current and voltages, and what really happens in a capacitor and an inductor. And you tie that in with real world knowledge, it'll take you very far. You'll have an understanding that would be unbelievable. It'll be a killer combination to know, you know, the concepts from a single electron to current flowing in transmission lines from one area to another. Anyway, so that's the video. I hope you enjoyed it. Please share your comments. Any other ideas that you've come across that you want others to know about. I would love to read them myself. Thanks again, and I'll see you in another video. Take care.